So the first question here is to solve the inequality minus 7 plus 2x is less than or equal to 1. So I suppose that's a big thing for me to understand straight away, is that means less than or equal to. Or equal to. If you don't understand that, you're in trouble. So in an inequality here, you've got minus 7 plus 2x is less than or equal to 1. You've got a left hand side and you've got a right hand side, and it's kind of telling you currently that the left hand side is less than the right hand side. So you approach this the same way you would do in solving. We're going to try and get the x's to the left hand side, and we're going to try and get the numbers on the right hand side. So hashtag dash there for the numbers on the right hand side. So I'm going to get rid of that minus 7 first of all, and to get rid of that minus 7 I'm going to add 7. That's the only way to get rid of it there. So I'm going to add 7. And if I add 7 to one side, I'm going to add 7 to the other side as well to balance it out. So we're going to end up with now the two of these cancelling out, and you'll be left with 2x is less than or equal to 1 plus 7 is 8. Of course, you could have done that a quicker way. Now this means 2x is less than or equal to 8. 2 multiplied by x. So you must divide by something to give your 1x there. So we're going to divide by 2. And we do that the other side. We'll divide by, if we divide by 2 on one side, we must divide by 2 on the other side. So now we're going to get x is less than or equal to 4. And there's our solution for solving the inequality. So part 2 then, so we're after working out that x is less than or equal to 4. And also another big part that comes back into play here now is x is this funky looking thing here, which basically means that x is an integer. And what the hell is an integer? Well, from your log tables on the day of an exam, you will see this z is equal to dot 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 minus 3 minus 2 minus 1 0 1 2 3 dot dot dot, which basically means that z is an integer and it's a set of positive or negative whole numbers. So you have to look at this and say, right, what are all the positive or negative whole numbers that are less than or equal to 4? Well, there's loads of them, and you must symbolize them by doing big dots on the number line there. And then I'll fatten up this arrow here, make it bigger, indicating that it's going on to infinity. And that's video number 1. So might need a bit of help with this one. I have no calculator, but a book costs €28 plus a delivery charge of €5. So I suppose the cost of the book is going to be £28 plus £5. So the total cost of the book is going to be £33. Now, what is the total cost of the book in euro if the exchange rate is £1 is equal to 1.25? So this is a very straightforward calculation because we're going from pound to euro. So if we're converting from pound to euro, well, whatever we're converting from, we need one of it. And we can clearly see here, whatever we're converting, when we're converting from pounds to euro, we already have £1. So £1 is equal to €1.25. If you didn't have whatever you're converting from, if you didn't have one of it, you'd have to find one of it. But we have one of it there. So once you have that, there's £1. And we now just need to work out what £33 is. And you multiply 33 by 125, and you end up with 41.25. Finito. This question says, using a calculator, multiply 450,000 by 7.8. So I'm just doing this here in the background, and the answer I'm getting when I multiply 450,000 multiplied by 7.8, I am getting 3,510,000 and that. And now I told you this idea now with scientific notation, because the answer says express your answer in the form a by 10 to the power of n, where a must be between 1 and 10. So the big thing from here, me in scientific notation, is you're going to have one non-single digit, or non-zero digit I should say, apologies, non-zero digit to the left of the decimal place. So one non-zero digit to the left of the decimal place. So if I look at this 3510000, the decimal place is all the way over here. So he's over there, and what I must do now is I must move him once, twice, 3 times, 4 times, 5 times, 6 times to get him into the correct position, which is now going to be 3.510000. How many? 1, 2, 3, 4 multiplied by 10 to the power of, I moved it once, twice, 3 times, 4 times, 5 times, 6 times. Moved it 6 times, and of course, really in shorthand, that is 3.51 by 10 to the power of 6. We didn't need to add in all them zeros. Calculate the measure of the angle B. Give your answer correct to the nearest degree. So this is a house that Ella's building in Montreal. And I suppose the big thing here is you've got to kind of abstract away all the stuff that's going on in here and spot that this is the angle that you're looking for, beta. Yes, this fella up here is called A, and this fella down here is called B. And you have a right angle in there, and you have 12 meters, and you have 6 meters. And our general rule of thumb for a right angle triangle, you have 2 things that you can do. You can either use Pythagoras' theorem to find one of the missing sides, or the other thing is trigonometric ratios to find maybe a missing angle or a missing side. We're looking for a missing angle here, so it's definitely trig ratios we're going to be using, which are our old friends silly old Harry caught a herring trawling off Achill. So the first thing we do is we identify the hypotenuse, which is always the longest side in the triangle, the side across from the right angle. We identify then the opposite, so the angle we're looking for is beta, so that's our reference angle, and the side opposite that is 6 meters. And then the fella that's left over, I always feel sorry for him, he's no choice in the matter. He's the adjacent. So now we go back to our roots here, and we write down our silly old Harry caught a herring trawling off Achill. And what we do now is we say to ourselves, okay, which one, so which side has no information at all? It's the hypotenuse there. So look at the hypotenuse and the hypotenuse. And as we're looking for one unknown already, as we are looking, so one unknown already, basically beta, if we use the hypotenuse, we'll have 2 unknowns and we can't figure it out. So long story short, the hypotenuse we can't use. And that means that we've only one choice. It eliminates it down lovely here. Tan of the angle is equal to the opposite side over the adjacent. And we're looking for tan of the angle beta is equal to opposite, which we figured out to be 6, and the adjacent, which we figured out to be 12. And now the last part here, so we have all these inverse operations in maths. The inverse of addition is subtraction, inverse of multiplication is division. The inverse of tan is tan inverse. Quite unusual. If it's cos, it'd be cos inverse. So you take the tan inverse of this side here, and you're going to be left with B, or beta. And if I take the tan inverse on one side, I must take the tan inverse on the other side. So you'll see you'll do your shift tan on your calculator, and there's a button there that looks a bit like this. I think it might have a bracket in it or something like that. You throw in the 6 over 12, which is what I'm about to do. Shift tan and 6 over 12, and press equals, and I get an answer of 26.565 and a bit more to it. And of course, with all these questions, give your answer correct to the nearest degree. So find the whole number part, look at the digit on the right. If it's 5 or greater, which it is, you round up. So our answer is going to be 27 degrees. So the previous question was about trig ratios, and here we're presented with another question involving a right angle triangle, and it's our old friend Pythagoras. Find the length of the roof from A to B. So from here to here. Give your answer correct to 2 decimal places. And again, I've done a bit of jiggery pokery here and got it already in the background, and I kind of abstracted away, took out the triangle there, put all the measurements on it, 6, 12. I decided to label the side AB X to make it easier. And our old friend Pythagoras here, which is the formula, the hypotenuse squared, oh sorry, I'm on rubber, so the hypotenuse squared is equal to the sum of the other 2 sides to be squared. So just in case you're ever asked that as a theorem or anything, reading it from left to right, the hypotenuse squared is equal to the sum of the other 2 sides squared. So we need to figure out this A, B and C here, and as always in our triangles, the hypotenuse is always the side that's across from the right angle, the hypotenuse, and of course that's going to be our C in the formula. And as we move from left to right then, left to right, I hit 12 first, so I'm just going to call it A for no other reason. That's just a nice way to follow something logically. A and then B. Of course, this could be B and this could be A. So starting to fill in here, we're going to get lots of things going on here. Let me see. So let's fill in our C first. Our C is of course our X, and our A then is going to be our 12 and then 6. And to working this out, we're going to get X squared, I think, is equal to 180, if I'm right. 12 squared plus 144 plus 36 is 180. Now, so we have again another inverse operation going on here. So of course multiplication is inverse operation is division. The inverse operation of squared is square root. And so we get, that will leave us with X, which is what we want. But if I take the square root of one side, I must take the square root of the other side. Let's do that in the calculator. So the square root of 180 is going to give us, let's see, I need to give it a different format. So it's going to give us 13.416. And this is correct to 2 decimal places. So find the second place of decimals. There's 1, there's 2. Look at the digit on the right. And if it's 5 or greater, you're going to round up. So we're going to end up with an answer of 13.42. R is the point minus 1, 2, and S is the point 5, 6. So this is our old friend coordinate geometry. We want to use the length formula here. So the length formula in your log tables, so the length of RS is given by this formula here. And it is x2 minus x1 all to be squared plus y2 minus y1 all to be squared. So you have to do a couple of things. First of all, you've got to label up here. You've got to label your x1, y1, x2, y2, just using the different colours here to make it a bit easier. x1, y1, x2, y2. So now when I belt into this question, setting it up here first of all. So points down, label, formula, set up. Same routine, always and ever, that I ever taught you. So x2 there, so there's the blue. x2 is, is red. So x2 is 5 and x1 is minus 1. If you're going to have negative numbers, brackets. Brackets there for negative numbers. So if you have negative numbers, make sure you put in brackets there. I'm going to highlight that, that's so important. So brackets for negative numbers, the whole lot. You know, and as you see there, I've got the brackets in, absolutely really important, you've got that in there. So now we put in the other bit. Y2 is 6, Y1 is 2, and finishing this question off, then we're going to get, well, just a bit of tidying up first before you get the calculator. So 5 minus 1 by minus 1 is going to be plus 1. And like, I mean, you can just get the calculator now for the rest of it. I'm going to do it out, but you can get the calculator there and work that out. That's going to work out to be 5 plus 1 is 6, squared is 36. 6 minus 2 is 4, 4 to be squared is 16. So you'll end up with root 52, which is perfect for your full answer. Or your calculator might tell you, would it be right in saying 2 root 13? And you don't need to give it to any decimal points or anything like that. So root 52, just have a quick double check, 2 root 13, and that question is done.